This is the moment a machine breaks free from the Earth's grasp.
A missile is an extremely complex, self-propelled guided munition system designed to deliver a payload. These systems rely on sophisticated guidance technology to ensure precision, trajectory corrections.
As the engine ignites, we observe Newton's third law in action. The extreme force of the plasma thrust.
The sheer power of ignition unleashes temperatures exceeding 3,000 degrees, testing the limits of aerospace materials.
Thrust has exceeded gravity. We have achieved stable trajectory.
Ignition. These first few seconds, before the vehicle clears the tower, represent the greatest structural threat of the entire flight profile.
Unlike jets, rockets carry all their fuel, including the vital oxidizer, or oxygen, needed for combustion.
The oxidizer tank holds the necessary oxygen in liquid form, crucial for igniting the engine in the vacuum of space.
Massive fuel burn for speed and altitude.
The initial stage provides the raw thrust needed to escape the thickest layers of the atmosphere, paving the way for maximum range and efficiency. Every ounce of metal saved, every component meticulously designed, is a testament to precision and the relentless pursuit of velocity. Weight reduction is not merely a goal. It is the fundamental physics that defines our ascent to the stars.
The pacing is set. This sequence is irreversible. All systems confirm discovery parameters.
The inertial navigation system is the core of modern guidance, utilizing sensitive gyroscopes and accelerometers.
Continuous calculation is the foundation of modern navigation, the core process maintaining position, velocity, and orientation without reliance on external signals.
There is no pilot, no remote control, only onboard computers.
Only the mission parameters are fixed.
The system is engaged in constant course correction, executing precise micro-adjustments to maintain trajectory.
These continuous, fractional changes ensure stability and mission readiness.
We are now experiencing a rapid increase in altitude, evidenced by the distinct thinning of the atmosphere and the dark.
Separation confirmed. We are transitioning from the boost phase to mid-course trajectory. All systems are nominal.
Guidance confirms a stable separation. The system coasting in the mid-course phase. Minor trajectory correction confirmed. The antenna deployment initiates the terminal guidance phase.
Velocity climbing beyond Mach numbers.
These monitors provide a real-time visualization of the reactor's internal state. Blue lines indicate stability, internal systems visualization, temperature, pressure, structural integrity, monitors active.
The nose cone features our patented multi-layer shield, ensuring unparalleled payload protection against kinetic and electromagnetic threats.
We have reached the critical approach vector. All systems are nominal for atmospheric reentry.
The sheer velocity causes rapid compression of atmospheric gases, generating immense friction and subsequently extreme.
It's a delicate balance of engineering, harnessing the intense thermal energy while ensuring structural integrity.
As the spacecraft hits the atmosphere, the heat shield undergoes ablation, shedding material to dissipate the intense heat.
We are currently experiencing temporary communication loss due to widespread signal interference.
Terminal guidance activation.
In this environment,
the simulations were wrong. It's escalating much faster than we predicted.
The mission is complete.
Where historical GPS offered only broad accuracy, often several meters off the mark, our modern VO3 tech—
Run through the stabilization sequence check again.
Confirmed, sequence is holding steady.
The interwoven strands of this advanced composite provide unparalleled strength. We've achieved a 20% increase in tensile students.
We've significantly enhanced the thermal resistance properties of this alloy, ensuring it maintains integrity. These systems perform millions of calculations every second.
The design emphasizes total system integration, leading to unparalleled functional convergence across all modules.
Despite their divergent purposes, both technologies rely on the fundamental shared principles of thrust and trajectory. From the desert floor to the silent void, the engineering demands precision.
Its design speaks to consequence, an inevitable capability.